Preparing for an AI systems engineer interview? You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. Walk me through how you would design a production LLM-powered feature, from request to response. When designing a production LLM app, I separate the system into API, orchestration, retrieval, model serving, evaluation, and monitoring layers. The request path should handle auth, prompt construction, safety checks, model call, post-processing, and logging. I design for latency budgets, retries, rate limits, and graceful fallback. The key is not just calling a model, but making the output reliable, observable, secure, and measurable under real traffic. While answering, focus on request flow, orchestration, model serving, retrieval, safety filters, observability, retries, latency budgets, and how production AI differs from a simple model API call. Question 2. When would you use RAG versus fine-tuning for an AI product? RAG is best when the model needs fresh, private, or auditable knowledge. Fine-tuning is better when I need to change behavior, format, tone, or task skill. In practice, I try prompting first, then RAG for knowledge gaps, and fine-tuning only when examples consistently improve performance. RAG adds retrieval latency and indexing complexity, while fine-tuning adds training cost and versioning risk. They often work together, not as replacements. Make sure to cover knowledge freshness, private data, behavior adaptation, cost, latency, evaluation strategy, maintenance burden, and why RAG and fine-tuning can complement each other. Question 3. How do you design a retrieval pipeline so an LLM answers using the right context? Retrieval quality starts before the vector database. I normalize documents, split them by semantic boundaries, preserve metadata, and choose embeddings aligned with the domain. At query time, I use hybrid search, filters, re-ranking, and top K tuning. I measure recall with labeled queries, not vibes. Bad chunks create confident wrong answers, so I treat indexing, evaluation, and feedback loops as first-class system components from day one. In your answer, talk about chunking, embeddings, metadata, hybrid search, re-ranking, top K selection, recall measurement, index refreshes, and how retrieval quality affects generation accuracy directly. Question 4. How would you reduce latency and cost in an LLM service without hurting quality? Latency optimization is a stack problem, not one trick. I reduce tokens through concise prompts, caching, streaming, smaller models, batching, and early exits. For serving, I watch time to first token, total decode time, queuing, and GPU utilization. Cost improve when routing sends simple requests to cheaper models and hard requests to stronger ones. I always protect quality with evaluation gates, because faster wrong answers are still failures. Be sure to mention prompt token reduction, caching, streaming, batching, model routing, quantization, latency metrics, GPU utilization, and protecting answer quality with regression tests before release. Question 5. What causes hallucinations in LLM applications, and how do you mitigate them? Hallucination is a reliability problem. The model generates plausible text without grounded evidence. I reduce it by constraining prompts, using RAG with citations, rejecting low-confidence retrieval, and asking the model to say when context is missing. I also add output validators for facts, schemas, or business rules. The best production approach combines grounding, evaluation datasets, human review for risky cases, and clear user-facing uncertainty signals. While answering, cover the difference between model uncertainty and missing evidence, grounding, citations, retrieval thresholds, validators, refusal behavior, human review, and hallucination-focused evaluations in production. Question 6. How do you evaluate whether an AI system is good enough for production? An AI system needs offline and online evaluation. Offline, I build golden datasets covering common, edge, and adversarial cases, then score with exact metrics, semantic judges, and human labels where needed. Online, I track task success, user corrections, latency, cost, and safety incidents. I avoid relying only on LLM as judge. It is useful, but it must be calibrated against human judgment and production outcomes over time. Make sure to cover offline golden data sets, task-specific metrics, human labels, LLM as judge calibration, adversarial cases, online A/B tests, safety metrics, and business outcomes after launch. Question 7. How would you version, deploy, and roll back models and prompts safely? I treat models like deployable software artifacts. Each model version has training data references, prompt versions, evaluation reports, container images, and rollback instructions. I release with canaries or shadow traffic, compare quality and latency against the baseline, and monitor for regressions. If the new model drifts or violates safety thresholds, rollback must be automatic or one command. Reproducibility is the difference between engineering and experimentation. In your answer, talk about model registries, prompt versioning, dataset lineage, canary releases, shadow traffic, rollback plans, evaluation gates, and reproducibility for incident response audits. Question 8. Explain data parallelism, model parallelism, and pipeline parallelism in distributed training. Distributed training helps when a model or batch does not fit efficiently on one accelerator. Data parallelism replicates the model and splits batches. Model or tensor parallelism splits model computation. Pipeline parallelism stages layers. I care about communication overhead, gradient synchronization, checkpointing, and fault recovery. Bigger clusters do not automatically mean faster training. Utilization, input pipeline throughput, and network topology usually decide the outcome in practice. Be sure to mention why distributed training is needed, how data, tensor, model, and pipeline parallelism differ, plus communication overhead, checkpointing, utilization, and failure recovery. Question 9. What are the key considerations when serving large models on GPUs? For GPU inference, I optimize both throughput and tail latency. Batching improves utilization, but large batches can hurt P95 latency. Quantization lowers memory and cost, but may reduce quality. KV caching, page detention, and efficient schedulers matter for autoregressive models. I monitor tokens per second, queue time, memory fragmentation, and OOMs. The right configuration depends on traffic shape, context length, and service level objectives under load. While answering, focus on batching, quantization, KV cache, memory limits, scheduling, throughput versus tail latency, tokens per second, OOM handling, and traffic-dependent tuning under load. Question 10. How would you design tool calling or agent workflows safely? Tool calling turns a language model into a controller, so I design it defensively. Tools need strict schemas, idempotency, timeouts, authorization, and audit logs. The model should plan minimally, call tools only when needed, and handle tool errors explicitly. For multi-step agents, I add step limits and human approval for irreversible actions. Without guardrails, agents become expensive, slow, and surprisingly good at making wrong API calls. Make sure to cover tool schemas, permissions, idempotency, timeouts, error handling, audit logs, planning limits, human approval, and risks of autonomous multi-step execution in production. Question 11. How do you handle prompt injection, data privacy, and security in AI systems? AI systems expand the attack surface because inputs can become instructions, data, and code-like behavior. I protect against prompt injection with instruction hierarchy, content isolation, retrieval allow lists, and tool permission checks. For privacy, I minimize log data, redact sensitive fields, encrypt storage, and enforce tenant isolation. I also test with adversarial prompts. Security cannot be a prompt alone. It needs system-level controls around every boundary. In your answer, talk about prompt injection, data leakage, tenant isolation, retrieval allow lists, redaction, encryption, access control, adversarial testing, and why prompts are not security boundaries. Question 12. What would you monitor after deploying an AI model or LLM application? I monitor AI systems at 3 levels: infrastructure, model behavior, and business outcome. Infrastructure metrics include latency, errors, GPU utilization, and cost. Behavior metrics include refusal rate, toxicity, retrieval hit rate, schema failures, and drift in embeddings or prompts. Outcome metrics track task completion and user satisfaction. When quality drops, observability should help me isolate whether the issue is data, retrieval, model, prompt, or traffic mix. Be sure to mention infrastructure metrics, model behavior metrics, drift, retrieval quality, safety incidents, cost, user feedback, business KPIs, and root cause debugging across components quickly. Question 13. How do you build a reliable data pipeline for training or retrieval-augmented generation? A good AI data pipeline is reproducible, validated, and traceable. I ingest raw data, run quality checks, remove duplicates, handle PII, label or enrich records, and version datasets. For RAG, I also manage chunking, embeddings, and reindexing. For training, I track feature transformations and splits. If I cannot explain which data produced a model output, debugging and compliance become painful during later incidents or audits. While answering, focus on ingestion, validation, deduplication, PII handling, labeling, dataset versioning, embedding refreshes, lineage, schema checks, and reproducibility for training or RAG pipelines reliably. Question 14. What changes when you build a multimodal AI system instead of a text-only system? Multimodal systems require aligning different data types into one task flow. For images, audio, text, or video, I think about pre-processing, model input limits, feature extraction, and output grounding. Evaluation is harder because correctness may be subjective or span multiple modalities. I design storage for large objects and metadata, then keep traceability between the original asset, derived features, and generated answer for reliable debugging and audits. Make sure to cover pre-processing for images, audio, video, and text, model input constraints, metadata storage, cross-modal alignment, evaluation complexity, latency, and traceability throughout the pipeline. Question 15. How do you decide between using an external AI API, self-hosting a model, or fine-tuning? When choosing AI architecture, I map requirements to risk, scale, and differentiation. If the core value is workflow and data integration, an API model may be enough. If latency, privacy, cost, or domain quality is critical, self-hosting or fine-tuning may make sense. I compare total cost, operational burden, evaluation results, and vendor lock-in. The best architecture is the simplest one that meets measurable product goals. In your answer, talk about product requirements, privacy, latency, cost, scalability, differentiation, operational burden, vendor lock-in, evaluation results, and choosing the simplest workable architecture for launch. If you are still with us, congratulations! You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.